Greetings and Assalamualaikum. Our group consists of Muhammad Alif Firdaus bin Alexander, Muhammad Nadim Akmal bin Arifin, and Daryl Sullivan Salibo. Wastewater is any water that has been utilized in homes, businesses, factories, or other sources that contains a range of toxins and pollutants. This covers water from sinks, showers, and industrial processes, among other sources. This wastewater need to be treated before being discharged because it contains dangerous elements that can endanger public health and the environment. The pie chart shows the wastewater capacity in Malaysia. As you can see, the highest is public sewage treatment plant, which is 36.3%, followed by individual septic tank by 26.9%. The third highest is pool flush, which is 15.8%, followed by regional plant 13.7%, and the next one is private sewage treatment plant by 6%, and the smallest one is communal septic tank, which is 1.3%.
Point 3. Wastewater treatment. Here are the several ways to treat water in Malaysia. Depending on the source and the quality of the water, here are some common wastewater treatment methods used in Malaysia. As we can see in diagram 2, coagulation and flocculation. Coagulation and flocculation, this process involves adding chemicals to the water to create flocks, which are clumps of impurities that can be easily removed by sedimentation or filtration. Coagulation and flocculation are effective in removing suspended solid, organic compound, and some metal. Secondly, as you can see in this diagram 3, reverse osmosis. Reverse osmosis, this is a process that involves remove dissolved salts and other impurities from water by forcing it through a semi-permeable membrane. Reverse osmosis is often used to desalinate seawater or brackish water. Thirdly, as you can see in this diagram 4, this is activated carbon filtration. This is a process where the water is passed through activated carbon to remove organic compound, chlorine, and other impurities. Fourthly, this is a diagram 5 which show a process of ion exchange. This is a process where ions in the water are exchanged with ion in the resin. Ion exchange is often used for softening water and removing heavy metals. As you can see in diagram 6, this is a membrane filtration. Membrane filtration is a process where water is passed through a membrane that removes impurities. Membrane filtration can be used for both microfiltration and ultrafiltration. Sixthly, this is a diagram which shows disinfection. Disinfection process. This is a process of killing or inhibiting harmful microorganisms such as bacteria, virus in the water. Disinfection can be achieved through chemical methods such as chlorination or ozone treatment or physical methods such as UV treatment. Thank you.
First stage of treatment and processing of wastewater is bar screening. Large objects must be removed from the effluent to avoid harming the facility's pump, valves, and other contents. The hope is that after treatment, the water will be safe to re-enter the environment. Next stage is graining. Grit removal by passing effluent over or through a grit chamber. This is to avoid harming pump and equipment downstream. Fine grit that enter the influence must be eliminated. The third stage is primary clarifier. Initial separation of wastewater and solid organic material. Sludge or organic solid are pumped to a digester or other location for processing, drying, and removal after they sink to the bottom of the tank. The fourth stage is aeration. To promote the conversion of NH3 to NO3 and to give oxygen for bacteria to continue to multiply and develop. Air is punished into the aeration tank or basin. Stage number 5 is secondary clarifier. Pumping treated wastewater through a secondary clarifier enables any lingering organic matter to spread out of the flow of treated water. The sixth stage is chlorination or disinfection. This is to eliminate any leftover bacteria in the contact chamber. Chlorine is introduced. It is necessary to analyze the departing influence for the presence or absence of bacteria and to disinfect the water because the aeration stage increases the concentration of bacteria. After that, stage 7, water analysis and testing. The performance of the plant depends on testing for the right pH level, ammonia, nitrate, phosphates, dissolved oxygen, and residual chlorine level to comply with the NPDES permits. And the final stage is effluent disposal. Clean water is restored into the environment once it has complied with all permit requirements. Final testing is performed to confirm that the effluent exiting the plant complies with permit requirement, even though testing is ongoing throughout the water waste treatment process to guarantee adequate water flow, clarity, and aeration. If a plant doesn't comply with the permit discharge limits, the operation in charge may be fined and or imprisoned.